Hello, this is William from Visual Components. In this video about physics, I'm going to talk about static and dynamic friction. In the 3D world, I have an example. This pink bar will push these green parts down this ramp. Right now the green parts are at rest, so the force that is keeping them there is called static friction, and that force needs to be applied to the parts to make them move. Now once the green parts start to move, that static friction becomes kinetic or dynamic friction, and that is a force that will try to stop the parts from moving. That force could be applied by other green parts, the surface of the ramp, or our pink bar here. Let's see how everything works out. I'll run the simulation. Here comes the pink bar. There is some resistance which causes some parts to fall off the side of the ramp, but the other ones should fall down the ramp. Here we go. Woo! Water slide! And they end up on the floor, and here comes a vehicle to push them out of the way. So when the vehicle pushes them, there is some resistance, that friction. And let's now reset our simulation. I'll clear my 3D world, and let's talk more about how friction works in the software. I'll go to the eCatalog panel and expand Models by Type. Click Physics. I'll now add an aero collider to the 3D world and make it into a ramp. So go to the Component Properties panel and rotate it around the x-axis by 90 degrees. I'll now edit its length property from a value of 600 to a value of 1500 or 1500. And here's the ramp. I'll now add a cylinder collider to the 3D world and move it on top of the ramp. I'll go to the Tools group and click Snap, and snap the cylinder right about here. I'll now go to the Component Properties panel and reset the rotation around the y-axis to 0. I'll now use the Move tool and move the cylinder up along the z-axis. Now if I run the simulation, you can see the force of gravity is not affecting the cylinder. To fix this, I'll reset the simulation, go to the Component Properties panel, click the Physics Entity tab, and change the Physics Type property from Kinematic to In Physics. And now when I run the simulation, the cylinder falls, collides with the ramp, and eventually it just falls to the side here. Let's reset. Whenever you are working with friction, you have to be aware of a couple variables. One variable is the restitution or bounciness of an object. So when the cylinder collides with a ramp, how much will it bounce back? And from that, how much friction do I need to apply to kind of keep it on the ramp? Another factor to consider is the momentum and velocity of the cylinder. So when it falls from a greater height, it'll have a lot more velocity, and then it'll come crashing down. So based on that, do I need more or less friction? And let's see how that works. If I move the cylinder very, very, very close to the ramp, let's see what happens. Oh, it eventually falls over, and now it's stuck, so there's too much friction here for it to fall down the ramp, and now it's just there. But you can see the cylinder is still moving because in the Component Properties panel you can see its location is being updated. Let's now reset and move the cylinder just a bit closer. Run the simulation, and eventually the cylinder falls down, but it actually stays in place. Let's see what happens when we fall from a greater height. So use the Move tool and raise it to the sky. Now it's going to fall with a lot of momentum. Oh, and we get a big bounce and it falls off. Let's now reset and move the cylinder back towards the ramp to right about here. Run the simulation, and that location is fine for the cylinder, but we actually want it to roll down the ramp and end up here. And let's see how we can do that by looking closer at the friction properties of our cylinder's physics entity behavior. I'll go to the Modeling tab. If you don't have access to Modeling tab, it's okay, just follow along. I'll now go to my Component Graph panel and select the Behaviors checkbox. I'll now expand the root node and its behaviors and select the Physics Entity behavior here. Let's now go to the Properties panel, and you can see that a physics entity behavior has two properties for friction: static friction and dynamic friction, and they have a default value of 0.5. These are coefficients of friction, so they have a value between 0 and 1. They're dimensionless, they're scalar values. And they directly affect the normal force that applies to this physics entity behavior, or this physical body. So when friction is at 0.5, we get this. So let's actually edit these values to have the part roll down the ramp. So we did a default value test. Let's now see what happens when both static and dynamic friction are at 0. I'll now run the simulation. Whoop! There it goes. So the part just slid on down because there was no friction stopping the cylinder when it collided with the ramp to slow it down, so it just went all the way down here. Let's now reset. And what you need to get used to is tweaking these values in steps. So usually I do the 0 test second after doing a default test, and then I test, okay, what happens if static friction is 1 and dynamic friction is 0? So let's now test. Oh, we get that. So when the cylinder collided with the ramp, it kind of jerked or snapped from that friction and fell over, and that's what's keeping it right here. Generally, you have more static friction than dynamic friction, but it can vary based on your use case in the 3D world. Let's now see what happens when static friction is 0 and dynamic friction is 1. And we get a little bit of jerk there, and then eventually the cylinder just falls down the ramp. So that's probably not what we want. And a good practice is kind of half the value you assigned. So I assigned 1 first, so let's do half of that, 0.5. And what we're trying to find is the limits for what is a good value to use. Let's now run the simulation. And yeah, that looked okay. So this time the part stayed upright and just slid on down. But let's see if we can use a smaller value. Let's try 0.25. And that actually looks okay. So it looks like 0.25 is an okay value to use for this test. But now, what happens when the part has a different orientation? Whoa. I'll select the root node of the cylinder. And now let's rotate the cylinder along the x-axis 45 degrees. And now let's see what happens using those values. So that was actually pretty smooth. If we reset, you can see that the cylinder is going to collide. It falls over, but it actually rolls down in a nice line. Let's see what happens when we change the friction again. So this time, instead of using dynamic friction, let's set that to be 0. Let's use static friction of 1. Aha! This time the cylinder collided and actually rolled to the other side of the ramp here. Let's see if we can change this a bit. Let's use 0.5 for static friction. Looks like we're getting a little bit of a roll there. Let's try all the way down to 0.25. And that actually looks okay, but now we just need some dynamic friction to kind of keep the momentum of the cylinder going down the ramp instead of, curving over here. So let's now try dynamic friction of, let's try 0.25, see if that works. No, not quite. Let's use 0.5. Oh, that was an interesting spin, but that's probably what we don't want. So let's actually use 1 for dynamic friction. And that's still just too much spin, so let's actually try 0.5 again. And let's try 0.1 for static friction. And we're almost there. Let's try a little bit more. Static friction of 0.3. That's still a bit too slow, so I'm actually going to lessen the dynamic friction and put it back to 0. Nope, still not working. So let's actually try a full value of dynamic friction of 1. No. So it does take some practice in finding the right values to use. I think in this case, I probably should just set static friction back to 0. Keep dynamic friction at 1. And nope, it seems that we had the sweet spot first, so 0.25 for dynamic friction. And yep, but that looked a little too fake. So let's try 0.5. And that time, yeah, so we found it there. So it does take some getting used to. One helpful tool is to visualize where the parts move during the simulation, and I'll show you how to do that now. But let's actually change the orientation of this part back to what it was. So I'll reset the rotation around the x-axis to 0, and I'll now snap the part directly to the ramp. I'm actually moving the feature, sorry. Let's actually move the component. And I did make a mistake, sorry. I need to correct that rotation I made to the cylinder feature. I just need to work with the component. So now let's snap the component. Let's change its orientation first before we snap it. Let's correct the rotations, make them 0. And I need to fix that error I made with the cylinder feature. There we go. So now let's take the root node of the component and snap it to the face center here of our ramp. So now when I run the simulation, you can see that the part is staying put because of the friction. And if I go back to the physics entity behavior, we're using 0.5 for dynamic friction. So to visualize how this part will move when we change the friction values, we can use a feature called sweat volume. An easy way to do that is to use a robot. I'll go to the Home tab, and in my eCatalog panel, I'll expand Robots, scroll down, click Visual Components. I'll now add my favorite robot, the generic articulated robot, to the 3D world. And from here, we can program the robot to sweep the geometry of this cylinder. And what that means is that every iteration or step of a process will kind of make a copy of the cylinder's geometry as it's moving. So if you have a broom and you start sweeping the floor, that's what we're talking about here. It's making a visual imprint of the geometry. So in the component properties panel for the robot, go down here to the actions configuration section and expand it. And by default, you can use signal 81 in the robot to turn on or off swept volume. Right now it's going to sweep the geometry of the robot. We don't want that, so I'll expand this and delete the robot from the list. I'll now use the pick command to pick the cylinder. So now I'm going to sweep the cylinder collider's geometry. And you could use the material of red, but I prefer to use a transparent material, or you could change the rendering option in the 3D world to X-ray if you need to. Let's find transparent red. Yes, right here. Now if you want to store the geometry of the swept volume during a simulation, you can select this option here. You just have to make sure that you turn off the swept volume using a signal as well. Let's now go to the Program tab. In the robot's program, I'm going to use a set binary output statement to set signal 81 to a true value, and this will turn on the swept volume. So now when I run the simulation, we get an indication of that swept volume here for the cylinder, and you can see it's not moving, but it is still rendering the volume there. Let's reset and now adjust the friction we have for the cylinder to move it down the ramp. I'll go back to my modeling tab. The cylinder collider, I'll select its physics entity behavior. And now let's change that dynamic friction from 0.5 to 0.25, half the value. Run the simulation. Woohoo! There we go. So we get the swept volume here showing the path of the cylinder. Let's take a closer look. I'll get rid of these lines. I'll just change my render mode to shaded. And this is actually interesting. So instead of going in a straight line down the ramp, the cylinder kind of curved this way and headed down the ramp. And you can see, because the swept volume is an iterative process, each iteration it looks like the cylinder was speeding up. So first it was kind of slow here, but eventually it gained some momentum. Let's now see what happens when we reset the simulation. The swept volume is gone because we did not turn it off and choose that option to store it. So now let's do a test dynamic friction at 0.125. And it looks a bit faster. Kind of hard to tell. Let's see what happens when static and dynamic friction is at 0. It looks a lot faster. So what we can do here to compare results is I will go back to the robot and go to the Program tab. And we're going to create a delay statement in its program. And we'll call that after we turn on swept volume. And let's run the delay for about 4 seconds. And then after that 4 seconds, let's turn off swept volume. So add a set binary output statement and set the value of 81 to false. Let's then select the robot as a component. Go back to the component properties panel in the actions configuration section. Let's look at output 81. And then we'll select this option here called store geometry. Now this will store the geometry in a new component. So that's what the swept volume will be attached to. You can choose, one of these other options, but I usually prefer the new component. Let's now run the simulation and then wait till the robot's program is ended, because that will stop the simulation. And now we have this saved swept volume. So if I select it, this is a component. I can move it. So I'll go back to the Home tab, use the Move tool, and here we go. We're now just moving a swept volume out of the way. So now when we reset, we can have another use case here, another visual imprint of what happened to the cylinder when it was moving down the ramp. So let's select the cylinder, go back to the Modeling tab and select its physics entity behavior, and let's actually use a static friction of 0.5 and see what happens. I think it'll just stay put. And it does. So we probably don't want that. So I'm going to reset the simulation before the robot's program ends, so that way the swept volume is not stored. So sometimes you want to give yourself enough time to record the movement of the part. Let's try a static friction of 0.25. And it is moving. And then we'll actually wait for the program to end so we can store it, reset, and now we have that copy there. It's actually interesting. Let's compare the results. So I'm going to select the component that stores the swept geometry, move it over here, and we can tell a couple of things from this. We can see that clearly both of the movements of the part did move kind of at an angle down the ramp, but in this case here, the part was moving a lot slower. That's why you have more imprints here, or records of the cylinder's geometry. Over here you can see they're more spread out, and that means that the cylinder was moving faster. So some food for thought if you want to keep on testing this yourself. Another thing to notice is that you actually can change the material of the swept geometry if you have access to Modeling tab. I'll now go there, and I can select this feature, and I can assign it a new material if I want to. I can go to the Geometry group, click the Tools drop-down menu, and then under Material, click Assign. Let's now assign this a different transparent color. So I'll go to my library of materials, look for a transparent material. We have a couple options here. Let's use green. Green sounds cool. So now in my mode, it's set to assign, and I want to assign the material to the feature, so I'll select it here. And then just click it in the 3D world, and now it's green. Oh. Okay, this completes the video. If you have any more questions, please feel free to visit our forum at forum.visualcomponents.com, and I hope you have a wonderful day.